Okay. So have you ever heard like somebody talking about machine learning?
Yeah.
And you kind of just want to like tune out because you think it's like way too complicated?
Yeah, totally.
Okay.
I get that. It definitely can sound intimidating at first.
Right. But what if we told you that like at its core, it's actually pretty straightforward?
Oh yeah, it really is.
And maybe even a little bit mind-blowing in how simple the basic idea is.
Exactly.
So that's exactly what we're diving into today.
We're going to break it down.
Like, what is machine learning, really?
Yeah.
And we actually looked at a bunch of cool resources to prepare for this. We've got like, those awesome YouTube explainer videos. Those are always so helpful.
Oh, yeah.
From channels like, Infinite Codes, Google for developers.
Those guys are great.
Simply Learn. They're all fantastic.
Yep.
And we even dove into this like super accessible ebook called Machine Learning for Absolute Beginners.
Oh, nice. A classic.
Really good.
Yeah.
Our mission for today is to help you walk away with like a solid understanding of the fundamentals of machine learning. Like, we want you to really get it.
For sure.
Not just like, oh yeah, I kind of heard of that.
Right.
But like really understand it.
And the cool thing is it's actually way more intuitive than people think.
Oh yeah, for sure.
Yeah.
And we're going to use like simple language examples that you can actually relate to in your own life. And we even have this really cool analogy that we think will help the whole concept just click for you.
I love a good analogy.
Yeah, it's going to make it stick.
Yeah.
Okay, so are you ready?
Let's do it.
Okay, so at its heart, what is machine learning?
So at its most basic, machine learning is all about teaching computers to learn from data, just like we humans do.
Oh, interesting.
But the amazing thing is they can do it without us having to give them explicit instructions for every single possible situation.
Okay, so it's not like writing code for like every single little thing.
Exactly. Like, imagine trying to write code for like how to recognize a cat. You'd have to account for every breed, every position, every lighting condition. It would be impossible.
Oh my gosh, yeah, that would be a nightmare.
Totally. So instead of doing that with machine learning, we feed the computer a ton of data, and it figures out the patterns, makes predictions, and gets better over time all on its own.
So it's like it learns from experience, kind of.
Exactly.
Okay, that sounds super powerful.
Yeah.
But I'm still a little bit fuzzy on the details.
Right.
Can we make it a bit more concrete?
Absolutely.
I know we had this idea for an analogy.
Oh yeah, the analogy. So think about how a little kid learns. A toddler. You see a dog for the first time. Their parent points and says, "Look, a doggy."
Oh, that's cute.
Right. They might describe it like, "Look at its wagging tail. It's got furry fur. It has a wet nose."
Okay.
And the kid sees all these different dogs. They hear that same label doggy, and they start to build their own understanding of what a doggy is. They learn from examples.
That makes a lot of sense. So are you saying the machine is like the toddler in this scenario?
Exactly. So in machine learning, we give data to a model.
Okay.
And this model is kind of like that toddler's brain, right?
Okay.
This data is made up of these individual learning opportunities. We call them instances. It's like each time the toddler sees a new dog, it's like a new instance.
Okay, I can see that.
And these instances, they have features, which are basically the characteristics that the learner observes.
Oh,
like, the fur, the tail, the size of the dog, stuff like that. And in supervised learning, which is one of the most common types of machine learning, we also provide something called labels.
Labels. So that's like when the parent says doggy.
Exactly. So the label is like the known correct answer that goes with a specific instance.
Gotcha.
So for our dog example, the picture of the dog, that's the instance. The features are all those visual traits, the tail, the fur, and then the label is dog. Now, the Machine Learning for Absolute Beginners book really hammered home this point about how important those labels are.
Oh, really?
In supervised learning. They're like, think of it like the answer key that the model uses to actually learn. Getting those good labels, though, that often takes a lot of work.
I can imagine.
Imagine like someone having to go through and manually label thousands of pictures of different animals.
Oh man, that sounds tedious.
Yeah, but it's super important because this well-labeled data, that's what lets the model actually learn effectively. They're the right answers that it can check its guesses against.
So it's constantly comparing what it thinks to what it knows is correct.
Exactly.
Okay, so the machine learning model is like the toddler trying to figure out what a dog is.
Yep.
And then the labeled data is like the parent patiently saying, no, that's a cat.
Yeah.
That's a dog.
That's a great way to think about it.
Okay, that's a much better way to visualize it.
Yeah.
Now let's zoom in on some of those terms we just talked about.
Sure.
You mentioned data and instances.
Mm-hmm.
What does a machine learning data set actually look like in practice?
So a machine learning data set, think of it as like this structured collection of all those learning experiences we've been talking about. Like the folks at Infinite Codes explained in their video, you can picture it kind of like a table, almost like a spreadsheet.
Okay, now I think.
Each row in that table, that's an instance, like one complete example, like one specific dog with all its characteristics.
Okay.
And then each column represents a feature, like a specific attribute that we're tracking,
Okay.
or the target. And the target is what we are trying to predict or identify.
Okay, so like if we were trying to build a model that predicts if an email is spam, what would that instance look like?
So in that case, a single email, that would be our instance.
Okay.
The features could be things like the words that are used in the subject line, the body of the email, the sender's address, whether it has links in it, all those things that might give it away as spam.
Okay.
And then the target, like Infinite Codes pointed out, would be the label, either spam or not spam.
Makes sense.
And the whole collection of all those different emails, each with its own features and its spam or not spam label, that would make up our data set.
So it's like features of the clues and the target is the mystery we're trying to solve.
You got it.
Now, you mentioned supervised learning relies on these labels. Can you unpack that a bit more for us?
Yeah, so in supervised learning, like both the ebook and that Infinite Codes video highlighted, the model is learning the connection between those features, the clues in the data, and their matching target values, the answers that we already know. Because we're kind of supervising the model by feeding it these examples where we already know the answer, like knowing which emails are spam.
Right.
The model can start to figure out, okay, these patterns in the features usually mean this outcome. That's why having that labeled data is so crucial for this type of learning. The model's always learning from those right answers that we're giving it.
Okay. That makes perfect sense with the spam email example.
Yeah.
So now, what exactly is the model itself? Is that like the computer program?
That's a great question. So the model, it's basically the algorithm. It's the set of instructions that's designed to learn from that data. And there are all sorts of different types of machine learning models out there. And they all have their own unique way of finding those underlying patterns in the data.
Interesting.
And you also mentioned parameters before. These parameters, sometimes also called weights, are like the internal settings or knobs within that model that it can adjust while it's training to make better and better predictions.
Okay.
Like if you think back to our toddler, as they see more and more dogs and they get feedback from their parent, their internal understanding of what a doggy is gets refined.
Yeah.
That's kind of what the parameters are doing. Like in a simple model that's trying to predict a line on a graph, the slope and the starting point of that line, those would be parameters.
So it's constantly tweaking those internal knobs based on the data it sees.
You got it. And Infinite Codes made this really important distinction between parameters and hyperparameters. Parameters, those are learned from the data itself. Hyperparameters, those are things that we, the people who are setting up the machine learning, decide on beforehand, before we even start training. Those might be things like how quickly the model learns or how many times it looks at the entire data set. They're like the main dials on our learning machine that we can tune to get the best possible performance.
Okay, so parameters are learned, hyperparameters are set by us. Got it.
Yeah.
Let's get into the learning process now. How does a model take all this data, all those labels, and actually learn something?
So the core of all this is a process called training. This is where we feed the model our training data, which is a bunch of those labeled examples, and the model starts to change its internal parameters little by little, trying to get better at predicting the target variable for each example.
Okay. And how does it know if those little adjustments it's making are actually making it better at predicting? Is there some way to measure its mistakes?
Yeah, absolutely there is. That's where something called the cost function comes in, also sometimes called the loss function or the error function.
Okay.
As Infinite Codes explained it, this function, it's like a scoreboard. It tells us how far off the model's predictions are from those actual correct labels in the training data.
Yeah.
Think of it like trying to get the lowest possible score in a game.
Right.
So for example, if we're trying to predict house prices, one common cost function is mean squared error, which Simplilearn also described.
Okay.
It basically calculates the average of the squared differences between the prices that the model predicted and what the house is actually sold for. The bigger the errors, the higher that cost is.
Makes sense.
So the whole goal of training is to find the parameters that give us the lowest possible cost.
So the model wants to minimize that error score. how does it actually go about tweaking those parameters to get that low score?
Okay, so that's where this really cool technique called gradient descent comes in. Infinite codes use this really awesome analogy of a hiker trying to find their way to the bottom of a valley when it's super foggy. So the hiker can feel the slope of the ground beneath their feet, right?
Yeah.
And they're naturally going to want to take steps in the steepest downhill direction.
Right, to get to the bottom.
Exactly. So gradient descent works in a similar way.
Right.
It calculates this thing called the gradient. It's like the slope of the error with respect to each parameter. And then it adjusts the parameters in the opposite direction of that slope. So it's like always taking a step downhill.
Okay.
And the learning rate, which is one of those hyperparameters that we talked about before, that controls the size of each step that the model takes on this downhill journey.
Okay. So it's like the hiker taking little steps, always trying to go down.
Exactly.
Okay.
And Infinite Codes also brought up this really insightful point. Just like that hiker could accidentally get stuck in a little dip that's not actually the very bottom of the valley, gradient descent can sometimes get stuck in something called a local minimum. It's a set of parameters where the error is low, but it's not the absolute lowest it could be. So they mentioned this concept of kind of giving the hiker some momentum to help push past those local minimas and hopefully find that true global minimum.
Well, that's a great analogy. So the hiker analogy really helps me understand that. What about these terms epochs and iterations? I know Infinite Codes talked about those. Those sound like they're for really big projects.
Yeah, you're right. Those become especially important when we're dealing with these massive data sets.
Okay.
So to make the training more efficient, we often break up that training data into smaller chunks called batches. An iteration is a single pass through one of these batches,
Okay.
where the model makes a prediction and then updates its parameters based on how wrong it was.
Okay.
An epoch, on the other hand, is a full cycle. It's where the model has seen every single training example in the entire dataset at least once.
Wow.
And this is usually done across multiple iterations if we're using those batches. Models often need to go through lots of epochs to really learn the patterns well. They're constantly refining their understanding with each pass through the data.
Okay.
But as Infinite Codes cautioned, if we train for too many epochs, the model can actually start to overfit.
Oh, what's that?
That's like when it's basically memorizing the training data perfectly instead of learning those general patterns that it can apply to new unseen data. It's kind of like someone who memorizes all the answers to practice questions, but then they can't actually solve a slightly different problem on the real test. They haven't really understood the underlying concept.
So it's not really learning, it's just memorizing.
Exactly.
Okay, so epochs are full cycles through the data and iterations of those many steps within those cycles.
You got it.
Got it. Okay, you promised us some real-world examples of machine learning in action. Hit us with them.
Okay, so Google for Developers gave this fantastic example of activity recognition on your smartwatch. So think about it. How could you possibly write rules to tell if someone's walking or running or sitting just from the raw data that's coming from those sensors in the watch?
Yeah, that would be so hard.
Like that their speed and their movement, it's way too complicated to code up by hand. That's where machine learning really shines.
Okay.
So by feeding the model tons of labeled data, like recordings of those sensor readings that have already been labeled as walking, running, or sitting, the model can start to figure out those really subtle patterns and relationships in the data that correspond to each of those activities. It can uncover the rules that we couldn't possibly write ourselves.
Wow. So it's like the machine learning model becomes an expert at interpreting that data in a way that we couldn't even program ourselves.
Exactly.
It's amazing. Okay, what's another example that we can really grasp?
Well, we've already touched on house price prediction. That's a really clear example of supervised learning where we're using features of a house to predict how much it's likely to sell for.
Makes sense.
The Infinite Codes video also mentioned email spam detection. We talked about that. Another great example is image recognition. Like, think about how your phone can automatically tag your friends in photos.
Oh yeah, that's so cool.
That's machine learning, hard at work. It's been trained on these massive data sets of labeled images.
So it's seen millions of faces and it knows what they all look like?
Pretty much, yeah.
Wow.
And it's figured out the patterns to be able to identify people in new photos.
That's really cool. Okay, so I can see how those all rely on having lots of labeled data. What about different types of machine learning?
Yeah.
SimpleLearn mentioned these things called decision trees, and they had this interesting golf example.
Yeah, so decision trees offer a totally different approach for machines to make decisions. Simple-Learn described it as like this flowchart-like structure where each node represents a question about a feature. Each branch is like a possible answer, and each leaf node represents the prediction that the model makes.
Okay.
So in their golf example, the tree might ask, is the outlook sunny?
Okay.
If the answer is yes, then it might ask, is the humidity low? And so on, eventually leading to a decision about whether to play golf or not. What's really cool about decision trees, the ebook also pointed this out, is that they're often very easy for us to understand. We can actually see the logic that the model is using, which isn't always the case for some of those more complex parameter-based models we've been talking about.
Right.
It's kind of like following a recipe step by step.
So it's much more like a logical set of rules than our parameter adjusting model.
Exactly.
Yeah.
Simple-Learn also gave an example of k-means clustering applied to cars.
Okay.
This is an example of what we call unsupervised learning,
How interesting.
which means we don't actually have labels this time.
Oh, okay, so the computer's on its own.
Exactly. So the goal here is for the algorithm to find these natural groups or clusters in the data.
Okay.
So in the car example, the algorithm might look at features like size, fuel efficiency, and horsepower of lots of different cars, and automatically group them into these clusters that might represent different vehicle classes like sedans, SUVs, and trucks.
Right.
And all of this without us telling it what those classes are.
Wow.
They even mention this thing called the elbow method. It's a technique to help you figure out how many of those clusters you should actually have.
Oh, cool. So unsupervised learning is about finding those hidden patterns when we don't already know the answers.
You got it.
That's amazing.
It's pretty powerful stuff. And I had one more really quick example, something that's super relevant these days.
Oh, yeah. What's that?
Face mask detection,
Oh, right.
which Simple-Learn mentioned briefly. This is a real-world application where a machine learning model is trained to look at an image of a face and tell us if the person's wearing a mask or not.
Okay.
And this is usually a supervised learning task where it would learn from a large collection of labeled images of people both with and without masks.
Okay. So after all of this learning, all this training, what's the result? What does a trained machine learning model actually do once it's ready?
So once a model has gone through all that training, it's essentially learned those relationships in the data, like that Y3X+1 relationship in the Google for Developers example, where it figured out that connection from the given data points.
Okay.
So at that point, we can use it to make predictions or classifications on brand new data that it's never seen before. We call that stage inference. You basically feed the model new inputs, features that it hasn't seen before, and it uses what it's learned to generate an output. That output could be a prediction about something, or it could be a classification, like saying this is a cat, this is a dog.
So we train it on those past examples, and then we unleash it on the real world to predict the future or categorize new things. That's the whole point, right?
Exactly.
Right.
This is so cool.
To summarize, machine learning is about giving computers this incredible ability to learn from data. And in supervised learning, this often means giving it lots and lots of labeled examples.
So it can figure out those hidden rules that connect the data to the answers we're interested in. It's just like our toddler learning about dogs. The more examples they see, the more feedback they get, the better they become at correctly identifying a dog.
Yeah, it sounds like while there are layers of complexity underneath, the main idea is actually pretty intuitive, especially when we think about it like a child learning.
Totally agree. And while there's a whole universe of advanced concepts and algorithms out there to explore, just understanding these basic building blocks gives you this incredibly solid foundation for understanding how machine learning is becoming a part of the technology we use every single day.
It's everywhere.
It's everywhere. And getting this basic understanding empowers you to look at the world around you with a more informed perspective.
This has been so insightful, a really awesome deep dive into the fundamentals of machine learning. Now for you, our listener, here's a final thought to chew on. Now that you have this clearer picture of how machines can learn from data, think about all those everyday technologies that you use. Which ones do you think might be powered by machine learning? And what kind of data do you imagine they're learning from?
It's a fun thought experiment, and we really encourage you to keep exploring this fascinating field. Maybe this episode has even sparked some ideas about problems in your own life or work that you could potentially solve using machine learning.
The possibilities are pretty much endless at this point. Thanks so much for joining us for this deep dive into the world of machine learning.
Yeah, thanks for listening.
We hope we demystified some of that jargon
For sure.
and gave you a really solid understanding of those core principles.
It's been fun.
It has.